Hello, welcome to episode 6 of Building Magic Polyglot Applications. This roadmap chart looks crisp and clear at 1080p as I record this, but I'm not sure how it will look when I upload it to YouTube, so I'll also stick a copy of it in the GitHub repository. Basically, this touches on all the little pockets of joy that we'll land on our journey to build and deploy web and SaaS product applications with Magic. The core technologies of Magic, Python, Tailwind, and HTMX form what I'm calling the math stack. Obviously, the P for Python is silent. Should I have named this the empath stack? Or maybe the pith stack? Who knows? Let's stick with math. Last time, I did a quick starter demo with Magic and HTMX. I have a great Tailwind intro episode coming up, and we've also covered some Python basics. Today we'll begin what will likely be a 3-episode story arc around authorization, authentication, security, user and role-based access management for Magic Web applications. We'll start here with some exposition and quick demos to show some concepts. And in a later episode, we'll show how we can manage all of this with Magic, and finally build a production-ready user access control component. Probably we've all rolled our own access systems for our Magic applications in the past, but I'm here to stage an intervention. Friends don't let friends build their own authorization systems anymore. I think it's now far easier, cheaper, more secure and compliant to leverage a hosted third-party solution. All the big cloud stacks provide identity management and allow you to provision API keys and control application access, but we're going to narrow it down initially to 2, Auth0 and Clerk. Today, we'll get started with Auth0. Next time, we'll see it work with Clerk. This is what we'll cover. We'll introduce JSON Web Tokens, abbreviated as JWT, but pronounced JWT. I'll show examples of both web application user authentication and managed machine-to-machine keys for an API, and we'll do this initially with Python. Now, JWTs are small in size and can be sent either as an HTTP header or as a post parameter. And JWTs are digitally signed and can contain a variety of information that we can really trust without worrying too much about whether it's been tampered with. You can think of it a bit like checking into a hotel. You need to go to the front desk, check in, present some ID, maybe your driver's license, for example, and that's equivalent to either a username, password, or client ID and secret with our applications. Once you've been authorized, the hotel reception then gives you a key card you can use to access certain areas, your hotel room, the lift, the gym or pool, etc., but not other people's hotel rooms or staff areas. A JWT acts a lot like this key card. The JWT contains a token you can present to access some of the things you're entitled to. Let's get started. Let's go to auth0.com and sign up for a free trial. If you want to follow along with the demo and the code that's in the GitHub repo, you'll need to create a few things in the dashboard. You'll need to define an API to manage. I've simply called it demo. And you'll need to define a couple of applications to be managed. One, the API that we'll see run using Python with the fast API framework. And the other, a regular web application demo written with the Python Flask framework. Actually, both of these demos are in the sample code library for Auth0. I'm keeping things simple for the demo. There are no granular permissions. All that you have to do is once you've got the application created, you just authorize it for the API. The Applications pane on the dashboard allows us to define the applications we'll authorize, what it calls machine-to-machine apps. And these are for back-end, background API calls. And it will manage allocating client IDs and client secrets. And we'll see those in use in the demo. And also we can configure options around how it creates the JWT tokens. Again, we control here which applications can access which APIs. When we get to the demos, you'll see that the second of them is just a regular web application. Traditional in the sense that we manage users, a user can log in, and this small demo has been built using Flask, which is why I've labeled it Flask app here. Again, we have a client ID and a client secret, and that's what the back end of the web app uses to verify tokens sent to the user when they're logging in or for subsequent app calls, and that's stored in the session cookie. For a regular web app, we have additional parameters to set, such as callback and logout redirects, and we'll see those in action. The Connections tab allows us to specify whether we allow single sign-on. Here we allow social sign-on via Facebook and Google, which I'll use in the demo. Also here, we define how the user list is actually stored. Now we can of course use our own database, but for this quick demo, I'm allowing Auth0 to manage the user list. Let's see where that's defined. Again, we simply authorize an application reference with a database reference. Okay, let's finally get to some code. The Magic Polyglot GitHub repo has been updated with an EP6 folder, which has 3 subfolders: Fast API, Flask, and mgauth. A file in the root of EP6, named notes.txt, has some install and setup instructions. Let's walk through it. I've opened the EP6 folder in Visual Studio Code. I've opened the terminal window, and I'll create the environment for Python with the command python-m venv. I then issue the activate command to start up the environment. Okay, good. Let's change directory into the Fast API folder, and we'll use pip install, the Python package manager, for some of the libraries we'll need. Fast API gives me a great framework to build APIs with. Unicorn gives me a Python async web server framework to host the APIs. And finally, PyJWT gives me a ready solution for working with JWTs. If only Magic made it this easy. It's kind of disappointing that there's no Magic support for such a basic feature, but that's why we're here. That's why we throw Python into the mix, and we'll make things work. If you don't want to work with Python, of course, you could also do all of this in C#, Java, or Go. Here we're looking at the .config file, and you should populate each of these key value pairs with whatever was set up in Auth0. So, client ID, the client secret, the issuer, the algorithm we're using. I'm using RS256, the API audience, and a domain. Just set that up. The file main.py is a really simple API with a couple of routes or endpoints defined, one public, one private. The private endpoint demands that we have a valid JWT token to be able to return the data. In this case, a very simple list of the payload that's actually in that JWT token. This relies on utils.py that contains both a function setup to read and use .config info, but also verify token, which makes sure we have a valid token issued by our provider, Auth0. It's simple enough, but if this is your first time seeing this, you'll absolutely have to play around with the code to make it real. let's use Uvicorn to host our API. Now, if we access the public endpoint in a browser, we get a simple response. Great. But when we access a private endpoint, we get a not authenticated response, which is a kind of success. Now, FastAPI gives us a Swagger document under Docs by default to let us test our API. This is really cool functionality that I'm going to suggest we also always use to wrap any magic APIs, but we'll get to that another time. So from here, let's see the public API work, and the private API says we're not authorized. Now this Swagger doc also lets us specify an HTTP bearer auth token. Let's grab one. Now in the same folder, we have a test client.py file that uses the client ID and secret to request a valid JWT token and write it to the command line that we can copy paste. Let's see this run in a command prompt. Change directory into the same folder. And run testclient.py. Okay, we can see our JWT and the fact that we successfully authenticated and got a payload in the token. We can copy paste that JWT. Now let's examine its contents with a utility hosted at JWT.io. This will allow us to decode our token. So we can see the JWT is comprised of three distinct parts. The header, which describes how it is encoded. The payload, which contains auth information, but also application-specific data we can customize. And finally, the signature section, which proves it's been signed in a way that shows it hasn't been tampered with, and we can verify that. Now, let's use that token again back in our API Swagger docs. We authorize our token. We hit the private endpoint, and boom, suddenly we can see the data returned from the private endpoint, which is actually a very simple representation of the JWT token payload. But that's what we wanted. Okay, that was a simple demo API. Let's now see a quick demo regular web application. Change directory into Flask. And let's pip install the requirements. Like last time, we need the key value pairs that specify the client ID, the client secret, and this time around we're going to put those in a .env file. We also need a random app secret key for Flask. And here we're going to use PowerShell to generate a GUID. Here we can run the Flask application in development mode by simply typing py space server.py. This will launch the server on port 3000. We can launch this in the browser and see a simple welcome page that also has a login link. Now if I hit login, we get a flow and dialog and sign in, sign up functionality from Auth0. I already signed up with a Google account, so I can now just use that account to authenticate. Auth0 takes care of all this for us. So we got a valid payload. Let's copy paste the token and see what JWT.io makes of it. So we got a valid token. We can decipher the header, payload, and signature. And we can set this as a cookie so that we can make subsequent requests as a user logged into the application. Let's take a look at the Flask application. I've defined a few routes. The one we just saw uses a template home.html. Flask's templating system works rather like HTML Marriage and Magic. We can see we have conditional logic to display the session cookie information and the payload in the pretty var when we're authenticated, when the session exists. In server.py, we can see the actual application, and we can see each of the endpoints that's defined, and we can further see that for only a few lines of code, we get incredible functionality. Now, the point of the lesson today isn't to teach you Fast API or Flask, but I will handle that in an upcoming episode. Even just to read the code, you can see that it's clear, concise, simple, absolutely effective. And it's this effectiveness that makes it a perfect companion to Magic for a hybrid web application. Now, a bit like the public-private endpoints that we saw in the Fast API demo, let's see how we can secure endpoints behind an authorization wall in Flask. We have an endpoint, hello, that's decorated with a function requires auth. If we look in decorators.py, you can see we have a function verify that we have a valid session. The hello world template here is very simple. Let's test it in the browser. When we're logged in, we see the page. If we log out, well, we coded a redirect to the home page. Looks good to me. Okay, last thing. And I'm not suggesting this is the only or ultimate way to interact between Python and Magic, but let's see a Python Flask application wrapping calls to Magic as the first step. Let's launch Magic and open the mgauth application. You can see it's basically a Hello World style Magic Web application. We are simply returning some text. It looks like a JSON object with a message, a timestamp, and we return the contents of a parameter based on a path variable. Let's put Magic into runtime and see this work. I have a simple template, magic.html, that displays nothing more than a hello world message and the data we receive back from Magic in a variable named mgdata. I have a catch-all route defined in server.py that handles all requested URLs beginning with Magic and passes the remaining path in a GET request through to the Magic application. Our application doesn't do anything special with it, but you can see that we might take different action depending on what's in that path. Nothing fancy, it's all hard-coded, it's just for illustration. I take the response and merge it into the template. In production, if we use this approach, we'd need some exception handling for the magic aqua screen of death. Let me first log in because this endpoint is decorated with request authorization. If we access magic/hello, you can see that we get a response that incorporates the data that we got back from magic. Now this might not seem that big of a deal, but suddenly we can now have magic APIs respond to patterns like true REST APIs and also handle more HTTP verbs such as put, patch, delete, in addition to the get and post that magic can only handle at the moment. Suddenly we can dine at the big boy table. Another crazy but entirely workable idea we can employ, that might not be for everyone, is that we could use a feature of IIS called IP address and domain restrictions to deny outside world access to the magic requester directly. And instead, we'd use Fast API or Flask as the gatekeeper to magic, meaning that authorization and access control is easily handled in Python, and we have core application functionality in a deeper backend beneath it with magic. Maybe we can think some more about that. Just for closure, we can see that the magic application that we've been using is also accessible directly from the magic scripts directory with the ISAPI DLL. Now, at least for the current version of Magic, XPA 4.9, there's no native support for Auth0 flows or JWT, so we'll always need to augment Magic with other things. And that's what we'll cover in an upcoming episode. The code-to-talk ratio in this episode wasn't so great, but sometimes we just need to learn to crawl before we can fly. That's all for today. I'll see you further on up the road, as a great bluesman once said.